Okay, hello everyone, and welcome to, I think, our 5th edition of FormIt Friday. This is Tom Villaro, and I'm the product manager for FormIt. And I have with me a few guests from the two teams that worked on FormIt this past release, and I'm happy to have some folks here to help explain in a little bit more depth the solar radiation feature, solar analysis feature, which we have as part of our FormIt 360 Pro offering. So why don't we just do a quick round of introductions. When we go first, David?
Yeah, this is David Shear. I'm a product manager on the building performance analysis teams, working on the solar analysis plugin in Revit and also the daylighting analysis plugin.
Great, thanks, David. Marcus?
Yeah, hi. This is Marcus Bond. I'm a developer on the FormIt core team. I have most recently implemented the solar analysis feature in FormIt, but I have an architectural background. I've worked on a whole bunch of other features too, but this was my recent endeavor in there. So I'll be talking a little bit today about the implementation in FormIt itself. Thanks.
Great. Welcome, Marcus. And Stephanie?
Hi, I'm Stephanie Egger. I work with David on the building performance analysis team, and I'm an evangelist for the team. So I work a lot with all of our users to make sure that they know how to use our tools well.
Great. Welcome, Stephanie. And of course, last but not least, we have Tobias Hathorn back with us.
Yeah. Hey, guys. Just wanted to give a reference for Marcus. We've done a couple of blog posts recently kind of spotlighting work by the development team, work done in FormIt and in real life done by the development team. And Marcus is the individual who's built the Chase Lounge, and he's also built, I believe, an outhouse with FormIt, kind of studying the kind of shadow impact that would have in the garden. They're actually linked, yeah, right there. So you could see a little bit of his handiwork, and so kind of putting a voice with the name too. It's pretty obvious Marcus spends a lot of time in FormIt.
Yeah, I like to build stuff. So
and with real world tools, right? Yeah, get your hands dirty.
Okay.
Excellent. So yeah, today we're going to do a little bit of a deeper dive into the solar analysis tools, like I said. And this is great that we have Marcus and David on and Stephanie, because really a lot of the analysis tools in FormIt 360 Pro are really the culmination of two teams working pretty closely together to bring this type of functionality into this conceptual design environment, and it's quite an accomplishment. So I'm going to spend some time today talking about that in detail. And just to get everybody back up to speed, basically what we released in May was a FormIt 360 Pro. So the core modeling and sketching and tools that we've had for a while in FormIt remain free, accessed from either the web interface or the mobile clients. And we added this optional Pro offering, which adds multiple features, specifically the solar analysis feature, which we'll be talking about today, and whole building energy analysis and real-time collaboration. So you can purchase this or start a 30-day trial right from within inside the web app. And then once you have a trial started or have purchased the Pro account, when you log into any of the three FormIt clients, Android, iOS, or web, you will get access to this solar analysis feature. So we're going to be showing it in web today, but just to keep in mind, once you have that account trial started or an account enabled, you can log in and use it in any of the three clients. So just to remind everyone, you can ask questions while we go in the question area of GoToWebinar. We will monitor those questions and try to get them in as we go. Feel free to just put those questions in as they come up. And we will be recording this. We are recording this, and we will be sharing that on our YouTube channel And I'm also putting together a web page with all of the past webinars and data sets. So you'll be able to actually download the files that we'll be showing in these various webinars. All right, so without any further ado, I'm going to hand it over to Marcus to start. He's going to take us into some of the ins and outs of the feature inside FormIt. So let me make you presenter.
Okay. Let me know, Tom, do you see my screen yet?
We do. Looks great.
Okay, perfect. Thank you so much. So, yes, we'll talk a little bit about the solar analysis feature in FormIt. As Tom said, this is a pro feature, but even in the free feature, FormIt gives you some basic analysis when the model interacts with the sun. Obviously, you're probably aware of that by modifying the time of the day and the day itself, you can get some accurate shadow studies from a given model. So I'm doing that. I'm just sliding the slider here, and you can, understand exactly what surfaces are shaded, so the impact of the sun for a given time of the year. So with the solar analysis feature, you can do quite a bit more of that. So let me maybe just execute that, just to give you a feel for how this works. So you enter this mode, solar analysis mode. You can see there's an orange border drawn around your model that gives you feedback that now you're in solar mode, and you expect it to just pick some surfaces that you would like to know more about, how much energy those surfaces receive. So I'm just picking a few here randomly, and then hit the Analyze button. So what this does is it quickly performs the actual calculations behind the scene, and then gives you this colored feedback in the model right in there. And so the way to interpret that is at the bottom here you have a legend with a color display that shows you what the colors mean, and it's goes from the left scale at 0 BTU per square feet up to the maximum for this particular location, which is somewhere around 289 BTU per square feet. So but comparing the color in the model into the legend, you get an idea of what the actual energy is received for this particular surface. You can actually get more detailed information just by moving the mouse over the surface and just hold it still for just a second, and you get a little pop-up there that gives you the exact number of that point. And what that number means for the current settings is the peak value that is received at that spot for a given month. And the month that's currently selected up here is July. So we have a slider that just allows you to go forth and back, and it will interactively update that. You can see as I'm going closer to January, obviously there's less exposure to that, and the darker color just tells you that there's less energy received than that. So this is how the basic interaction works with that. Just play with it and understand the values. But what we really try to do here is to kind of customize or tailor this for a particular workflow. Like, what would I really use this for? And let me just do that, reset this for a second, and just maybe hone in on 2 of those surfaces. So these 2 vertical surfaces here, the south-facing this particular model, this happens to be a nature center in Columbus, Ohio, where I'm actually located. And I'm going to pick these and analyze this again for the month of July, and move my mouse over there, and it tells me I have about 110 BTU per square foot exposure. So obviously the idea would be that we want to minimize the amount of solar impact for like cooling loads for this particular model. So one of the things I can do now is employ certainly modeling techniques, changing the geometry a little bit to have less exposure on there. So let me just go out now and maybe do things like move this facade, this edge a little bit so that the facade is slanted. Hopefully that less sun will hit it, create a little overhang. Or in this side over here, maybe just create an overhang like that. So I'm just doing a few modeling steps. Go back into the solar analysis tool and pick those 2 surfaces again. and perform another analysis. Okay, so that's interesting. So the one surface that has the slanted surface now only shows me 47 BTU per square feet. Just by doing this little move, I can cut down the amount of energy received in the summer by half. The overhang was maybe not quite as efficient. Obviously it depends on the direction of the light here. So some part of it is nicely shaded. The lower part still receives the original amount of sunlight. We just maybe go back to a couple of different times of the year. Maybe January, you can see that I'm back to a higher amount of energy because obviously the sun comes in at a lower angle. And maybe that's actually good. In the winter, you may want to capture some of the sunlight for passive energy gain. And in the summer, we get the nice effect from shading in there.
So that's cool, Marcus. On the overhang that you did, you didn't need to choose any of the surfaces from that overhang in order to have those impact the results on that face.
Yes, correct. Only the surfaces that I'm picking actually analyze. I mean, if I wanted to, I could actually find out, what does the actual overhang itself get? So I just pick it and then analyze. Obviously, this will get a lot more energy. Yeah, you can see it's yellow.
Mm-hmm.
But what I was really interested in was just the impact on the face below.
Yeah, that's great.
Yeah. So, actually, I have another model here. Let me just go back to this one. Show something similar. So this is a hotel in Las Vegas, and we'll go into the solar here and see what we get. So analyze maybe this face here. And see what we get. And by the way, we have a little north arrow here that shows up at the bottom of the screen that helps you understand which direction actually your geometry is facing. So obviously Las Vegas, gets a lot of sun. You want to minimize impact there too. And so maybe one study you want to do here is create some kind of shading device, maybe balconies that could act as shading devices, little overhang like that, and then copy that down. And I cheated here. I already modeled this. I'm just using the undo redo feature to get this back instead of fumbling with modeling tools here.
That's a good demo trick. I got to remember that.
Yeah. Since we're not really focusing on modeling techniques here, I thought it would be easier just to talk over that. So we go in here, and I can also show you that instead of just picking faces individually, you can just use the area tool, just drag it around and grab a whole bunch of faces and analyze that.
Marcus, we had one question about reflection, and you can see, you're starting to see some impact from those solar shades, but does the rendering take into account light bouncing off the solar shade back onto the surface to bring the value back up a little bit, I guess?
Yeah, that's a good question. And David, correct me if I'm wrong, but no, it does not. So the way the actual algorithm works, it takes into account the direct contribution from the sun itself, and also sun that is scattered in the atmosphere and from the sky dome itself. But it does not take into account light that's reflected off of other surfaces in the scene.
Okay.
Like, for example, the famous Michael Graves, goof up of the, I think it was Performing Arts Center in Los Angeles, where his highly polished steel panel facade, or whatever it was, in a concave facade, basically created a big concentrating lens of the sunlight onto the opposing office building and frying it. That we could not model that.
Okay.
Yeah.
Yeah, if you wanted to look at light reflections, you can use the lighting analysis tool in Revit, and that will actually consider light reflections.
So anyway, so here in the Las Vegas hotel, down here is still the original sun exposure of about 150 BTU per square feet, and down at the shading, we cut it down significantly, hopefully reducing the energy load quite a bit on the facade. And there. Okay, let me go back this one real quick and show you there's another mode that we have. So this gives you the peak per month, which is good for shading design. The other mode we have here is a yearly cumulative. So what this will tell you is what's the total amount of solar energy that's received on a given point or surface in the model. And that's really useful for, let's say, solar panel design. We will reset that. Obviously, you wouldn't put solar panels here on the facade, but maybe on the roof surfaces. So to understand exactly how much energy we have we're receiving on these surfaces, we pick these and then analyze that. So, so that again, you see the color displays. You can move your cursor over that. So that's 1,260 kilowatt hours per square meter. And knowing this number and the type of solar panels that you have, you can do the calculations whether this makes sense to put a panel there, and if so, what the payoff period is, by which time the panel has paid for itself. Also in the range there, so we switched this over to kilowatt hours per square meter. Obviously, this is a metric unit, but this is the preferred measure that's used in the industry to judge that. So in here also you see the maximum range for this particular location. So Columbus, Ohio, you could get up to 1,503 kilowatt hours per square foot if you oriented your panel properly in the optimal direction. And we can actually do that. So again, with modeling steps, you could do a couple of exercises here. Maybe change the slope of your roof here and move it up. Or I pre-modeled maybe a bunch of surfaces that could host solar panels, just a bunch of faces that I've located here. So if I go back into solar analysis and then maybe pick these and just analyze those. And we get here. So 1,462 out of 1,503 maximum, so that's probably pretty good. It would also tell you if you made those panels too big that they're self-shading. That might not be such a good idea. So with simple few modeling steps, you can maybe rectify that and make these a little bit smaller. So those are the two kind of important workflows that we try to address with that. The other thing I maybe want to quickly touch upon is how do we know that these numbers that we actually calculated here are really correct? I mean, numerically and physically correct. So we just put these numbers up, and who knows whether that actually is true or not. So we're using a fairly sophisticated algorithm to calculate the sky contribution, both from scattered light and the direct sun contribution. It uses weather data from the actual location. That's actually the critical part, where cloudiness and exact sun radiation is recorded and then becomes an input into the calculations. And we also verified all these algorithms against a government provided solar calculation that we can actually execute. So I'm just switching to this data, to this website here. It's by NREL, which stands for the National Renewable Energy Laboratory. It's a government organization that provides energy services for consumers and industries. And they have a little calculator here that allows you as a consumer to calculate what the energy would be for a given location. So I'm just going to do a little exercise here to show you how this would work. So I'm entering a particular location. In this case, I just picked Boston as I could model for that. And then, oops. Of course, now it doesn't work. This website sometimes goes down. Go back here. Restart that. Boston, Massachusetts. Okay. Hopefully it's online now. Yes. So then I can just put in some values for a fictitious solar panel and its orientation. So I'm just going to design a flat panel, input the angles, how it would be rotated in 3D space, and then let it analyze that panel. And it will give me back the solar radiation for that location and that panel orientation. So this comes out to be 3.92 kilowatt hours per square meter per day average. If I multiply that number, it comes out to be 1,430 kilowatt hours per square foot. So if I would then compare this to a FormIt model, so you have a box. This is in Boston here. You can see the location here, Massachusetts. So if I go into my solar analysis and analyze that top face, that horizontal surface, I should be getting pretty close to 1,430. So I'm getting 1,413, so within a few small percentage points of the real data that's verified by the government. So maybe that is a good point where I can actually hand this over to David, who's the actual real expert on energy analysis, and he'll show you the Revit plugin, solar radiation plugin. So Tom, can you make David presenter?
Sure. Thank you, Marcus.
Yeah.
But I'm going to pass this over to you.
All right, let me know when you can see my screen.
Yep.
Okay, looks like we
Got it? Great.
Yep.
Yep.
Yeah.
So one thing I really appreciate about FormIt is the interoperability with Revit. Anytime you save a FormIt file to 360, it's turned into a Revit file as well. So there's kind of a seamless connection to a more detailed workflow in Revit. So we've created the solar analysis plugin for Revit. And if you do a search on the web for solar analysis for Revit, you'll see the Autodesk Labs site where you can download the plugin. It's currently in labs in beta format as we flesh out some more workflows, but it's fully functional and available in 2014, 15, and 16. So this is actually the model that Marcus was working with in FormIt, opened up in Revit. And you can see it's basically the same model. We've set up the plugin to be as push button as possible for analysis workflow. So currently we're starting out with just one analysis type, but as we move forward with this tool, we'll be adding analysis types to this list. For instance, for PV workflows, window loading, site analysis, things like that. So we'd love to hear input from customers like you on workflows that you would like to see covered in a more automated way with this tool. Currently, this is a really open tool, a very, very flexible tool with a lot more settings that are available in FormIt right now. So it's a little more tedious to use, but it's got still got a lot of functionality. The basic process is to select your analysis type. Again, select your services. Here, I'll click through a few of the roof services, like Marcus did in FormIt. Finish that selection process and click the Analyze button. And we're using the exact same algorithm here in Revit as we do in FormIt, so you should get the same results as in Revit as well. So here we can see right off the bat which our roof service is going to be the best for solar panels, for instance. I won't go through a lot of the design workflows. I think Marcus covered those really well. I want to more show you the functionality available in Revit, and then hear from you folks on the workflows you're interested in. But the basic settings are we can set a range for using the sun settings dialog. The nice thing about this is that you can set the range that the analysis tool uses. And then you can also visualize that range by turning on the sun path. So the sun path that we see in each view is actually the range of solar insolation that influences the results on the model. The analysis grid is a simple setting to set our analysis precision. We're actually generating a series of analysis points in the model, and you can set a more detailed or less detailed grid depending on how fast you want to do your analysis run. So we can do a points view with the analysis visualization framework, which we use to visualize the results and see that we're actually analyzing a number of points, and those can be visualized in a number of different ways. And then the results metric, where you can switch between, like Marcus pointed out, the cumulative and average installation, as well as the peak hour of your time period. Changing your units and then manipulating the analysis visualization framework styles. So on this detailed workflow, as you move into Revit, we can use the tools that in Revit that allow you to move from a mass services to more detailed modeling services. So for instance, if I want to start looking at, well, for instance, in this model, let me start looking at these window services. So I know I've got some window services here that I want to look at, but my mass model really doesn't have enough detail to look at roof overhangs. So if I want to get into a shading design with more detailed geometry, I can start to add some detailed modeling components to it. And I've got a model that I've taken a couple steps to add, basically turn mass services into roof services, where I can start to very easily vary the roof overhangs and then regenerate the analysis results. And in this case, I'm setting the sun settings to be a time span that includes the hours of the year where my energy analysis has told me that I've got overheated hours or high window loads. So I want to really shade the window services during those times of the year. And then continuing on to the detailed model, one thing we've recently opened up with this tool is that you can do analysis on any detailed modeling services, not only mass services in Revit. So here's that same model taken to another level of detail, where I've got full shading devices, full window design, roof overhangs with all the detailed parapets. And I can continue the analysis to make sure I'm following through on the results that I hope for at the detail level. So typical analysis procedures. Thank you. Yeah, typical analysis processes here include looking at window loading, PV design, and site design. So shading will be generated by trees, by any detailed model services, etc. So let me hand it back to you, Tom or Marcus.
Hey, David, I had a question for you. Actually,
Sure.
Kind of two questions. One is, looking at this, the more detailed workflow, does this start to address the question that came in earlier about the reflection? I couldn't tell for sure if this is still just the solar analysis tool or if this is also the lighting analysis tool.
Yeah, this is the solar analysis tool, which doesn't consider reflections off of objects right now. Okay. The lighting analysis tool will consider those reflections, and that's available in the same place in Revit on your Analyze toolbar. Here's the solar analysis button, and these are the lighting analysis buttons. And there's a number of webinars, recordings, I think, available on the lighting analysis tool.
Okay. So you get the solar analysis plugin from Labs, and then it shows up here on the Analyze tab?
That's right. Download the plugin from Labs, install it for your version of Revit, and it'll show up in the Analyze toolbar.
Okay, awesome. Is it the same for lighting analysis, or is that already in 2015 and 2016?
It's also a plugin right now, but it's a fully supported product, so it's got an actual product page. And if you look up lighting analysis for Revit on the web, the first link should be the product page for that.
Okay, cool. And does that render in Revit, or does it render in the cloud?
The engine for solar analysis is in Revit. The thing that we've done over the last year with this tool, with the algorithm, is to really speed up the calculation method using a cumulative sky method for the Perez model. So we've got the industry standard calculation with a really fast calculation engine.
Cool.
So we can actually do that calculation in Revit. With lighting analysis, we use a cloud service. It's a little more complex calculation, still fairly fast, but it takes about 5 or 10 minutes for a model like this. And by calculating it on a cloud service, we don't take up computer resources, and we can do it faster.
Yeah, that's nice. The other question I had was around the default colors, and this is one area that I know Steph is pretty passionate about. So I didn't know, maybe she wanted to talk a little bit about the analysis visualization framework so that you could kind of customize that piece.
Yeah, so this is actually one of my favorite features in Revit. I know it's a little funny, but I absolutely love it. And what it does is, you know, it helps you kind of look at different options for viewing your analysis results. And this is going to be for solar and or lighting. So as David pulled up, you know, you can control your legend. This becomes really helpful. So for example, if you want to highlight results above or below a specific value, you can build that in. So right now David has, you know, just an automated max and min legend. But let's say we want to call out and clearly identify any values, you know, above 15,000, we can color code that in so it becomes really clear. So we can start to identify those types of pieces.
That is awesome. Whoa.
Yeah, and it's good for highlighting, you know, areas, you know, for certain qualifications, or you kind of, if you have some idea of values you want to see, if anything above might be kind of considered bad and you might want to reduce it, it's pretty easy to help call that out. And I think David also showed, you know, you can see this color gradient, but he also had one of the views enabled where it was this analysis points. And it kind of just depends on your preference on how you want to visualize your results. And it's really about making your analysis results work for you, making them kind of customizable and more powerful.
Yeah, that's pretty cool. And it's also kind of like a good distinction between what FormIt is and what the plugin in Revit is that, you know, we've got kind of an easy out-of-the-box scenario with the default colors in FormIt right now, but as soon as you want to get to more detail and have more control over those visualizations, you can basically just take the same model and bring it on into Revit and then have this control just right out of the box.
Absolutely. That interoperability and design continuity piece is really key for being able to continue your analysis.
Yeah, that's a good point, Tobias. You know, under the hood, Revit and FormIt, you know, employ the same algorithm calculations, but FormIt, you know, kind of hard codes or wraps it into kind of two workflows. But Revit really gives you the full spectrum of customizability of what you want to see, different periods to look at, different hours of the day to look at. You know, there's really a great deal of flexibility in there that makes this worthwhile to look at in more detail in Revit.
And it looks like Tom included where you can access the link to labs for the solar analysis piece, so you can check that out. You know, it's free to download and free to play with right now, so it's a good thing to test out.
Yeah, and I don't know if that'll show up. Oh, sorry, Tom. I don't know if that'll show up in the recording. So if anybody's watching the recording, I think if you just Google solar analysis for Revit or lighting analysis for Revit, you'll hit those.
Yep.
And David, can we talk at all about plans for graduating from labs, or should we wait for another time for that?
Yeah, I think we can wait for another time, but mainly I'd like to emphasize that we're collecting information from customers about what they'd like to see. The solar analysis plugin is a way to access very detailed analysis capabilities, but also we want to automate a lot of functions. So it's the process of running typical analyses is very fast, and you can just select a simple setting and get the answers to the questions you want. One thing I should also mention is that these capabilities are available in Dynamo as well. We'll be updating those to 8.1 pretty soon. I think the old versions have a date timeout issue right now, but we will be supporting the solar analysis for Dynamo, so you can even go to the next level of very detailed workflows using the same algorithm.
Right, yeah, that's great. And that really kind of highlights what we're trying to do sort of post Vasari in terms of taking technology that we developed and experimented with in Vasari, and now taking that same sort of calculations and technology and making it available in different formats depending on your use case. So sort of kind of simple and quick analysis in FormIt, and more detailed analysis in Revit, and then maybe getting it even into sort of generative feedback loops using that data in Dynamo. So this is a great example of, spreading the functionality out into different clients, not trying to, shoehorn it into a single place.
So,
there was one other question about the lighting analysis feature only being available in Revit 2015. Is that correct?
Actually, we just finished our 2016 release, so it's available in 2014, 15, and we'll get the 2016 build out in hopefully today or tomorrow.
Oh, okay, great. Yeah, so that page will be updated then with that download link. Okay, great. So stay tuned for that.
So you're the first to know. This is the announcement. Sorry for the delay.
Yeah, that's great. All right. Well, we don't have many other questions right now that are open on the question pane. We can probably wrap this one up. I'll give kind of people one last chance to post a question, but I wanted to thank Marcus and David and Stephanie for joining us, and we're going to be expanding this webinar to include customer presentations as well very soon. So just to kind of give a plug for the Revit Technology Conference, which is in middle of July, just actually in a few weeks. We'll have a couple customers there. Actually, one, Tony Caputo from Array Architects, is going to be doing, I know part of his presentation will show how he's using the solar analysis on some specific healthcare projects they're working on. And I know we have Ryan Cameron and Sean Burke and Tobias. Do you remember any of the other FormIt specific?
Yep. Jared Schultz is also going to be presenting at RTC North America on FormIt. Yep.
Yep. So if you're not attending RTC this year in Washington, we will. I'm going to try to get at least a few of the FormIt presenters and have them represent their content in this format on FormIt Friday, so we can get people access to those great presentations if you were unable to make it live. And then
That's
were
awesome.
just in the process of finalizing AU courses, and there'll be some announcements of that soon. But stay tuned. We have some good FormIt classes lined up for AU this year too, so that should be exciting coming up in early December, I think. So with that, I think we will close it off for today. This has been recorded. I will make the recording available either later today or on Monday, and we will also make these data Revit and FormIt data sets available on this newly formed FormIt Friday webpage on our blog, which I have to create today. So stay tuned. I'll send out a follow-up email and tweet with that link once I have it ready, and look forward to seeing everybody next time.
Cool. Thank you.
All right. Thank you,
Thanks,
guys.
everybody.
Bye-bye.
Thanks, everybody. Yeah.